On May 1, 1960, the Central Intelligence Agency lost communication with a highly classified reconnaissance platform operating deep within sovereign hostile airspace. The aircraft was a Lockheed U-2C, identified within the CIA and Lockheed program as Article 360, and bearing the United States Air Force serial number 566693. The mission was Operation Grand Slam. Piloted by Francis Gary Powers, the objective was the systematic collection of photographic intelligence across a vast continental landmass. The operational stakes were absolute. The mission included contingency measures intended to prevent the most sensitive reconnaissance equipment from being captured in usable condition. Those measures could damage selected systems, but they could not guarantee the destruction of the entire aircraft, its film, or every classified component. If the hardware fell into foreign hands, it would generate a physical contradiction that no diplomatic maneuvering could erase. Operation Grand Slam was not a routine border patrol. It was an ambitious reconnaissance flight of approximately 3,800 miles, beginning in Pakistan and intended to cross a vast section of Soviet territory before terminating in Norway. This massive distance imposed severe physical and mechanical constraints on the single-engine aircraft. Every component of Article 360 was stripped down to maximize range and ceiling, leaving a fragile airframe built entirely around its central mission requirement. The U-2C was visually distinct, featuring elongated glider-like wings designed specifically for stratospheric flight. This unique geometry could not easily be disguised as a standard civilian airframe if recovered in large, coherent sections. The flight path demanded precise navigation across thousands of miles of hostile terrain, with narrow performance margins and limited tolerance for mechanical failure or operational deviation. The primary intelligence payload housed within the equipment bay was a Hicon 73B panoramic camera. This was not a standard observation tool. It was a massive, highly complex optical instrument designed to capture high-resolution imagery across a continuous swath of ground. The Hicon 73B was engineered to operate in the extreme cold and low pressure of the stratosphere, utilizing tightly wound spools of specialized film. The intelligence value of this film was absolute, containing detailed photographic records of sovereign military installations. Its complex lenses, heavy film magazines, and specialized optical housing made the mission's true purpose physically undeniable. The camera was the reason the flight was authorized, but it was also the greatest operational liability. If the aircraft failed to complete the 3,900-mile transit, the intact recovery of this single piece of hardware would immediately expose the operation. When the platform failed to emerge from hostile airspace on May 1, 1960, United States officials began preparing a previously established cover response. On May 3, while the fate of the pilot and the extent of the Soviet recovery remained unknown in Washington, the government released the first public version of that narrative. United States officials issued a formal statement claiming that a National Aeronautics and Space Administration weather research aircraft had gone missing. The cover story asserted that a civilian pilot conducting high-altitude meteorological sampling had experienced a failure with his oxygen equipment. According to this fabricated narrative, the incapacitated pilot lost consciousness, and the unguided aircraft simply drifted off course across the border. This narrative was a calculated institutional gamble. The weather plane cover story was fundamentally incompatible with the physical reality of the hardware deployed. A meteorological research flight carries atmospheric sensors, while Article 360 carried the Hicon 73B panoramic camera and specialized electronic intelligence gathering equipment. The diplomatic shield relied entirely on the opposing government being unable to present the actual wreckage. Officials expected a catastrophic loss at extreme altitude to kill the pilot and leave too little usable wreckage to disprove the civilian explanation. The ultimate question was how the extreme operating altitude of the aircraft influenced the assumption that the physical evidence could never be captured intact. Operating at 70,500 feet established a strict spatial geometry for the reconnaissance mission. This extreme altitude was the primary operational defense, mathematically calculated to place the aircraft entirely above the vertical tracking and engagement envelope of known ground-based interceptors. Planners relied on this geometric limit to ensure the physical security of the platform. That physical boundary collapsed when a Soviet S-75 Dvina surface-to-air missile successfully tracked the target and breached that ceiling. The weapon did not achieve a direct kinetic strike on the central fuselage. Instead, a missile detonated close behind the aircraft, subjecting it to a violent blast and fragments that caused catastrophic structural damage and an immediate loss of control. Whether the entire tail assembly separated at that moment remains unconfirmed. The catastrophic damage destroyed the aircraft's aerodynamic stability and triggered an irreversible collapse of the flight path. As the aircraft entered an uncontrolled spiral and tumble through the stratosphere, the severed airframe rotated rapidly around its new center of mass. This uncommanded rotation generated extreme centrifugal forces that pushed all loose mass outward toward the extremities of the airframe. The violent motion threw the pilot forward toward the nose of the aircraft and pulled him out of the proper seating position. The sustained forces restricted his movement. This centrifugal pinning effect directly compromised the primary security directive of the operation. In the event of an unrecoverable failure over denied territory, the pilot was expected, if circumstances permitted, to activate the device in an attempt to disable the camera and selected classified equipment. The internal security protocol included a 2.5-pound explosive destruct charge positioned near the reconnaissance equipment. Activating it required a deliberate sequence of 4 manual actions, after which a 70-second delay was intended to give the pilot time to escape. However, the system still depended on the pilot remaining physically capable of reaching and operating its controls before leaving the aircraft. Pressed heavily against the forward glass and instruments by the relentless rotational force, the pilot was physically prevented from moving his arms back to reach the arming switches on the console. Unable to initiate the destruct sequence, the pilot faced a secondary, immediate hazard regarding his own survival. The primary egress method was a specialized ejection seat. Like the destruct timer, the ejection system was a rigid mechanical process that demanded strict physical conditions to operate safely and effectively. Firing the ejection seat required precise physical alignment between the limbs of the pilot and the structural envelope of the seat itself. Because the centrifugal force had displaced the pilot forward and completely out of the prescribed seating posture, his legs were pushed outside the designated safe extraction path. Initiating the rocket firing sequence in this displaced position would drive his lower body directly into the rigid steel rails of the canopy frame. This ejection envelope geometry presented a lethal egress trade-off. Powers believed the seat could sever his legs. Faced with that danger, he decided not to use the seat and instead attempted a manual bailout. While still pinned by the intense rotational forces, he reached the canopy latch and manually released it. The canopy tore away instantly in the high-speed slipstream, altering the aerodynamic drag on the spinning airframe. The pilot released his restraint and was thrown partly out of the disintegrating cockpit rather than climbing clear in a controlled movement. For several moments, he remained connected to the aircraft by his oxygen hoses before they finally broke and allowed him to fall free. His parachute deployed successfully, allowing him to survive while the disabled aircraft and its undestroyed reconnaissance equipment continued toward the ground. The 70-second timer was never triggered, leaving the 2.5-pound destruct charge dormant inside the equipment bay. Once the pilot separated from the aircraft, the falling reconnaissance hardware was subject only to gravity and impact forces. The crash site contradicted that expectation. When the aircraft disintegrated in the stratosphere, the structural components did not vaporize. Instead, the extreme altitude of the breakup generated a massive debris scatter footprint. Heavy mechanical components like the single engine, lighter structural wing skin, and dense internal payload packages separated in freefall. Each element took a distinct ballistic trajectory toward the surface, based on its specific weight and aerodynamic drag. The falling components were scattered across rural terrain in the Sverdlovsk region, with wreckage recovered in the area around Koszalino. The precise dimensions and distribution of the debris field remain unconfirmed. This high-altitude debris scatter transformed a localized crash investigation into a massive geographic search problem. Hostile forensic exploitation required bounding this enormous footprint to recover specific intelligence components before weather degradation or local civilians could interfere with the site. Soviet authorities moved quickly to secure the area and collect the scattered wreckage, assisted in the first stages by local civilians who had encountered the pilot and debris. The precise search pattern, perimeter structure, and field organization used during the recovery remain unconfirmed. The primary objective of this expansive ground operation was not merely to collect aluminum scrap to confirm the loss of an aircraft. The absolute priority was to isolate and locate the specific reconnaissance payload that would definitively identify the origin, capability, and purpose of the unauthorized flight. As the ground teams systematically closed the search grid, they successfully located the shattered remains of the forward equipment bay. Within this tightly packed wreckage, forensic recovery teams identified the primary internal security mechanism of the aircraft. Investigators determined that the onboard destruct mechanism had not been activated. The precise condition in which it was recovered and the method by which Soviet personnel rendered any remaining hazards safe are unconfirmed. Securing and disarming the cyclonite explosive was a critical operational checkpoint. It neutralized the immediate hazard, preserved the camera and nearby equipment from the damage the charge was intended to inflict, and granted investigators controlled access to the most critical section of the debris field. Adjacent to the disarmed explosive, the search teams achieved their primary objective by recovering the central intelligence asset, the Hikon 73B panoramic camera. Soviet personnel recovered camera components and film in a condition that permitted further examination. The precise combination of shielding, separation, and impact conditions that allowed this survival remains unconfirmed. Inside the rigid housing, the specialized film was wound tightly under high tension onto solid metal spools, and the film magazines protected at least portions of the exposed material from complete destruction or light damage. The recovered film gave Soviet technicians an opportunity to develop and examine the imagery. The next procedural challenge was extracting the tightly wound film from the damaged casing without accidental light exposure, which could erase the captured data before its intelligence value was accessible. The forensic analysis of the physical hardware was conducted in parallel with direct human intelligence gathering. Powers was first encountered by local civilians before being taken into Soviet custody, establishing a direct human link to the mission. Interrogators immediately worked to extract flight plans, navigation waypoints, and primary operational objectives from the captured personnel. However, human testimony is inherently vulnerable to diplomatic denial. The opposing government could easily assert that the pilot was confused, coerced, or operating a benign civilian flight that strayed accidentally due to physical incapacitation. To establish absolute, undeniable proof of a coordinated espionage campaign, the physical photographic evidence had to corroborate the human data independently. In secure, completely dark facilities, Soviet technicians carefully disassembled the armored optical housing. They extracted the continuous strip of specialized film and initiated a meticulous chemical development protocol. The precise technical parameters of the foreign film, including its chemical emulsion composition and optimal development time, were highly specialized. This required disciplined calibration by laboratory specialists to ensure the visual data was not ruined during processing. The development protocol succeeded, unlocking the visual data captured during the cross-border transit. The processed negatives yielded incredibly sharp, high-resolution reconnaissance views of Soviet territory and military-related targets along the aircraft's route, including highly classified military installations. The developed film, recovered route materials, aircraft equipment, and Powers' identity reinforced one another, firmly connecting the physical evidence to a deliberate reconnaissance mission. The photographs also demonstrated the optical system's capability. The trade-off edge of possessing captured foreign technology lies in the tension between technical secrecy and diplomatic leverage. Keeping the hardware secured within a closed laboratory maximizes the long-term engineering value that can be extracted from the asset through continuous reverse engineering. However, the successful hostile forensic exploitation of the optical payload provided the Soviet leadership with a different strategic option. They chose an immediate diplomatic and propaganda strike, bringing selected wreckage and recovered evidence to Moscow for public exhibition, while technical examination continued behind closed doors. This movement transformed the recovered hardware from a classified engineering asset into a highly publicized political weapon. In Moscow, engineers and state curators organized a massive exhibition of the shattered components of Article 360 inside Gorky Park. The teams did not attempt to restore the aircraft to a pristine or flight-ready condition, although some pieces were arranged and partly reassembled for identification and display. Instead, they displayed torn wing sections, separated fuselage panels, engine components, and other wreckage in a presentation that emphasized the aircraft's catastrophic destruction. Around these heavy airframe sections, the curators strategically positioned the undeniable proof of the espionage mission. Camera equipment, pilot gear, route materials, developed reconnaissance photographs, and other recovered items were arranged alongside the wreckage for public inspection. The exact condition of every camera component and the identity and status of any displayed destruct device parts remain unconfirmed. The diplomatic trap began before the public exhibition. On May 5th, Soviet leader Nikita Khrushchev announced that an American aircraft had been shot down without revealing that the pilot had survived. After the United States committed itself to the weather research explanation, he disclosed Powers' capture and the existence of recovered evidence on May 7th. The sheer volume, specific technical nature, and undeniable authenticity of the displayed hardware, including the specialized high-altitude camera and the military-related targets visible in the developed imagery, rendered the civilian weather research defense completely void. Confronted directly with this curated forensic exhibition, the United States was boxed into an immediate strategic retreat. The shoot-down, the failed cover story, and the public confirmation of the reconnaissance program poisoned the approaching Four Powers Summit in Paris. When the summit opened on May 16th, Khrushchev demanded an apology and other concessions that President Eisenhower would not accept, and the meeting collapsed. The crisis forced a rare and damaging public acknowledgement of the American reconnaissance program, sharply weakening the plausible deniability on which the operation had depended. After its immediate political use, the wreckage entered a new phase of institutional custody. Today, major sections of Article 360's wreckage and associated artifacts are displayed at the Central Armed Forces Museum in Moscow, while other authenticated fragments have entered collections elsewhere. The exact metallurgical degradation of the scattered components over decades remains a continuous curation challenge. The curators at the Central Armed Forces Museum inherited a massive, fragmented collection of highly stressed aerospace aluminum, heavy steel engine components, and specialized optical housings. Their primary conservation decision was to preserve the wreckage in its recovered, visibly damaged state, rather than present a complete, pristine reconstruction. Some recovered sections were aligned, fastened, or arranged only to make the remains intelligible as an exhibition. Curating this exact state of destruction requires active environmental stabilization. Aerospace aluminum alloys are highly susceptible to galvanic corrosion and surface oxidation when exposed to fluctuating humidity and temperature cycles over decades. Long-term preservation of the airframe would normally benefit from stable temperature, humidity, and protection from active corrosion. although the museum's exact environmental specifications for this exhibit are not publicly confirmed. The large wing panels, heavy turbojet engine, and remaining fuselage structures are mechanically supported to limit long-term collapse under their own static load. The exact design and structural calculations of those mounts are not publicly documented. Beyond the bulk aluminum airframe, the museum also manages the diverse material composition of the classified intelligence payload and pilot survival gear. Any surviving optical equipment, textiles, rubberized components, and pilot gear require different conservation approaches from the exposed airframe metal. The precise identity and condition of every object currently held with the wreckage should be treated as unconfirmed without a detailed museum catalog. The rubberized seals, pressurized fabrics, and intricate optical glass are highly sensitive to ultraviolet light exposure and atmospheric moisture. Such materials would normally be protected from excessive ultraviolet exposure, moisture, and unstable environmental conditions. But the museum's object-specific control measures are not publicly confirmed. Any authentic destruct device components retained in the collection would require documented safe status and appropriate museum monitoring. Whether the original complete charge is present, inert, and maintained under a specific inspection program remains unconfirmed. The Central Armed Forces Museum now functions as a public repository for some of the physical evidence that survived the incident, preserving access to the intersection of high-altitude espionage and forensic recovery after its intelligence and diplomatic use had ended. The museum's detailed conservation regime and the artifact's permanent future, however, cannot be guaranteed from the available record.